So I'm going to do 3 examples for you using the law of sines and the law of cosines. The first example is find the measure of the angle B. And you can see here I've been given 20 degrees for angle A, and I've been given the length of the side opposite angle A. So it kind of looks like the law of sines here, where I'll take the ratio of these two sides. And if I do the ratio of these two, this is better. If I do the ratio of these two, then I'll only have one unknown, which is the angle C. From the angle C, then I could find angle B, because the interior angles of a flat triangle add up to 180 degrees. And then from there I could find B if I need to. So what are they asking for? They're just asking for angle B. Okay, so that's the plan. I'm going to take the ratio of the sine of this with 2 and the sine of C with 4. Solve for C, and then subtract C and 20 from 80 to get B. That's, I think, the way I did this. Let's see. So I would first set the mode on my calculator to degrees, since this is in degrees. Now you could just change everything to radians, but I think for this one it's easier just to change your mode to degrees. So I want to find angle C first. Why am I finding angle C first? Because I have all but one piece of information to find angle C using the law of sines. The only thing I'm missing is angle C. And that's because I know the length of this side, little c, which is 4. Okay, so I'm trying to use information that I know. And so that's the trick here. Don't try to find B right away. Okay, so back up here a little bit. So I have sine of C over its opposite side, 4, equals sine of 20 over the length of its opposite side, 2. And that means that sine of C equals 2 sine of 20 degrees. Oops. Let's back this up a little bit. Now, so what I've done here, I don't know why I didn't just write 2 sine 20 degrees, but I left that as 4 over 2 for some strange reason. I think it's just because I was just going to plug this in and estimate. So why C1? Well, there's 2 possible angles C where the sine of C equals this quantity on the right. One of them is the arc sine of 2 sine 20 theta. And so I stored that in memory C so I can recall it later. So what I'm thinking of is this picture in the CS plane. I've got the sine of something, and the 2 sine 20 degrees is a positive number. So I know it's in the upper half plane. The arc sine, or the inverse sine, is always in the right half plane. So that's going to give me this one. But there's still this other one, which is going to be pi minus this one. Right? Or, I'm sorry, we were in radians. I'm sorry, we're not in radians, we're in degrees. So it would be 180 minus C1 is the other angle. So you have to keep track of this stuff. Every time you do an arc sine, you have to ask yourself, or any inverse trig function, you have to ask yourself, is there more than one value that works? Because the inverse trig function only gives you one. It's kind of like doing the square root. You ask yourself, okay, do I need the plus or minus square root? or do I just need the plus square root? It's this very similar kind of thing. So the angle will be one of these two. Now it's not going to be this plus 2 pi or anything like that, because these are interior angles of a triangle. So they have to be less than 180 degrees and greater than 0 degrees. So these are the only two. Okay, so that's my C2, and I put that, and I just typed it in this way, 180 minus, I did the memory C, right? And then I stored that in D, memory D. And these are the two triangles, just to show you what's going on. I drew the triangle that looks like this smaller one over here, but that the drawing doesn't really mean anything. It's the numbers that matter. So if I took this 2 and swiveled it over and extended this line, you'd see it forms an isosceles triangle here. And this is another possibility for the opposite. See, the opposite side is 2, just like here. The side opposite the 20 degrees is 2 for this bigger triangle. This side's 4, and this side here, the opposite side is 2, and that side's 4, and this is 20 degrees. So it still satisfies, both of these triangles satisfy the criteria here. That is, both triangles include this angle A. So this one here, and this one here. So I'm just showing you how we can have two different angles here. Remember, this is angle C. And this gives us two different angles B as well. So this is kind of a tricky question. Find the measure of angle B. There's two possibilities. There's two answers. Okay. So actually finding it is not that hard. I just take 180 minus 20 minus C, which is my C1, and I get approximately 116 degrees, 116.84 degrees. And then B2, I do the same thing, but I subtract D, which was C2, and I get 23.16 degrees. So that's this one here. And I colored them, so this is orange, the orange one, right? And this one here, the red one, is this one here, right? And I'm just using there that they add, the three interior angles add up to 180. So if I take 180 minus the other two angles, I get angle B. Now I did that with both of them. So I hope that makes sense. The only tricky part there really is you could get half credit for getting one of the answers and not getting the other answer. There's this, because this arc sine here doesn't give you all the possible answers. If it was a cosine, this would have been the arc cosine. It actually would have been a plus or minus for that thing, which would look kind of like the square root thing. But this is a rule of sines, so it'll always be sines. So example 2 is apparently a shorter one because there's less space. Find the length of the sides B1 and B2 in example 1. Little b1 and little b2. So that's from this picture, from this illustration here. So b1 is from here to here, and b2 is the shorter one from here to here. I colored them if you can see that, orange and red. Okay, so how do we do that? Well, b over sine b equals a over sine a. You might think, well, but the law of sines has those upside down. It doesn't matter. As long as you flip both of them, you can have the sines on top or you could have the sines on bottom. It doesn't make any difference. It still holds true. And why did I put the sines on bottom? Because I'm trying to solve for b. Okay. So a we already know is 20 degrees. I use the a because this, if I used if I used C, there's two different ones, and I didn't want to bother with that. So there's only one angle A. That's the one we know for sure. So B1 is 2 times sine B, capital B1 over sine 20. And so I just put that in the equation, put this here, in here, put it in the calculator, and calculate it. So it's pretty simple. And then for B2, I just do the same thing, but I use this angle here, in here. So that would be B2, capital B2, right? Right, in case you were wondering where does this 2 come from, the 2 here is actually, that's the B. I forgot to mention that. Or wait, no, it's the A. The sine opposite, or the length of the side opposite angle A is 2 for both of these, right, both triangles. So that's 2 there always. So this is 2, this is, this is A, little a, over sine of capital A, angle A. And then I just had this sine of B1 down here, and I moved it, I cross multiplied. Okay. And then you do the same thing with B2, and you get approximately 2.30. And those are lengths. They didn't say what the units of the lengths are, so they don't have units.